Chapter 12, Compressible Flow. All right, class, today we are going to imagine we are playing with air instead of water. Until now, we always thought air didn't really change much when it moved around. But when air moves very fast, like in rockets, fighter jets, or popping balloons, it behaves differently. This is what we call compressible flow. Imagine you have a balloon. When you squeeze it, the air inside gets packed tighter. That's because gases, like air, can be squished or compressed, especially when they are moving fast. So in compressible flow, the air can change its thickness or density as it moves. Now, if we want to understand how fast air is moving, we compare it to how fast sound travels in air. This special speed is called the speed of sound. If you are slower than sound, it's like a quiet breeze, called subsonic. If you go exactly as fast as sound, we call it sonic. And if you go faster, it's supersonic, like a rocket zooming across the sky. We even have a number for it, called the Mach number. Mach 1 means you are moving at the speed of sound. Mach 2 means twice as fast, and so on. When air goes fast, it doesn't always behave smoothly. If you have a nozzle, like the end of a water hose, it can make air speed up or slow down. With subsonic air, if you make the pipe smaller, the air speeds up. But when the air gets to the speed of sound, the smallest point, called the throat, is where Mach 1 happens. After that, to make it go faster, you need to make the pipe bigger again. This is called a converging-diverging nozzle. It's like squeezing a balloon, letting the air out through a tiny point, and watching it zoom out even faster. Another fun thing happens when air goes too fast and then suddenly slows down. This makes a shock wave. Imagine clapping your hands really fast, creating a loud pop. A shock wave is like that, but it happens to air itself. This causes the air to suddenly change speed, temperature, and pressure, just like a big surprise slap on the air. Engineers study this to make sure airplanes don't get damaged when flying very fast. Also, when we push air through pipes or nozzles, sometimes the flow is nice and smooth, called isentropic, meaning no heat is added and everything changes gently. Other times, like when there's friction or shocks, air gets hotter or loses pressure suddenly, which makes things more complicated. In real life, this knowledge helps us design engines for planes and rockets, nozzles for fire hoses, or even medical devices like oxygen masks. We want to know how fast the air is, what its pressure is, and how much force it makes. We even have special tools like wind tunnels, where we blow air around small models to predict how big airplanes or cars will behave. So remember, when air moves slowly, it behaves calmly and simply, but when it rushes really fast, it can squish, speed up, slow down suddenly, and even make loud booms. By understanding compressible flow, we can make sure our vehicles fly safely, our rockets launch properly, and our machines work efficiently, all by learning the secret behavior of fast-moving air.